Time to look at logistic regression. In particular, I want to focus on some of the math behind logistic regression. So, what is logistic regression? Logistic regression is a standard classification machine learning algorithm. Like linear regression, logistic regression finds weights for each column of data. Unlike linear regression, logistic regression splits the data in half. Logistic regression uses the sigmoid function to convert all outputs to 0 or 1. Logistic regression is a classifier, not a regressor, even though it's called logistic regression. Why? It's like regression. The name regression started for regression to the mean. And like, I think there's a thinking that it's like regression to the line, to the curve. Okay. I know it's not the best explanation, but I think that's where the general idea comes from. It's kind of confusing, honestly, because it's a classifier, not a regressor. All the other classifiers have classifier in their name. Okay, so how does it do this? It uses the sigmoid equation. And there you have it. Beautiful curve. This is the answer to, hey, if I could have x, or t in this case, be any value, my inputs, but I wanted to restrict the outputs to values between 0 and 1, how could I do that? This is how you can use the sigmoid. It's 1 over 1 plus e to the negative t. Note that it could be x, e to the negative x, same thing, and that e is about 2.7. Okay, so let's look at this in a little more detail. So here are the positive x values, and what happens with those? They're mapped to class 1. So it's everywhere in the red curve, but logistic regression maps the sigmoid anything greater than 0 to 1. Similarly, if you look at the y values, these are all mapped down to 0. So again, sigmoid equation is the red curve. Logistic regression maps everything in the red curve to the left of 0 down to 0. And for the values in the middle, well, depends which side, really, right? They have the greatest uncertainty, I guess is the point. They could go either way, but clearly if it's to the right, they go up. If it's to the left, they go down. Now the sigmoid ranges from 0 to 1, kind of cool. And these values may be interpreted as probabilities. This is key. Probability is going to be a topic that you'll see coming up when we're trying to interpret and figure out what's going on using deep learning. And so how does it work here? This point has a y value of 0.98, so there's a 98% probability it belongs to class 1. This point has a y value of 0.2, so there's a 20% probability it belongs in class 1 and 80% probability it belongs in class 0. And this point, oh my gosh, it's sort of in the middle, but clearly it goes to class 1 because the probability is greater than 50% that it's in class 1. If it's smack in the middle, I think you put it at 1, but it could go either way. So how does logistic regression work? Weights are randomly chosen to multiply each column. The sum of the weighted columns becomes the t value, really x value, but I use t because the equation provided here was t. The t value is placed in the sigmoid equation and mapped to 0 or 1. And the percentage of correct predictions is returned. Weights are adjusted depending on the error using gradient descent. Another iteration continues, and the iterations continue until the error is minimized. Same as linear regression, it's just the mapping is different, right? Uses the sigmoid. Okay, you still multiply and add them all up, but that value goes into the sigmoid equation and then it's mapped to 0 or 1. Let's do it with code.